Okay, we have a bunch of bus routes connecting everything together. And a person called Bai lives in North End and wants to take a holiday in Seatown. So I'm assuming that must be North End, and that would be Seatown. And our question is, Bai considers traveling by bus along the route N to O to S. This was done very quickly and easily, this question. So obviously, how much you have to pay. If that's the bus fares, it's 15 plus 105. 15 plus 105 equals $120. Don't forget to dollar sign, people. It's probably where the very small people who got this wrong went wrong. All right, we want to know what is the cheapest route from North End to Seatown. Look, I'm just going to draw a line right through the middle, straightforward, knowing that is not going to be the answer, but can I make that any cheaper? That gives me a, so far, target score of 100. All right, so now I'm just going to consider, like, are there any other alternative paths that would be okay or not? Look, if I do that, that's 35, so that's not an improvement, so I can ignore that. What if I did that? Definitely not, because that's way more than we had before, and I'm pretty certain we're not going to be doing anything involving this line. So any sort of diversions up and down there, or up and down there, or up and down there, none of those are going to make that cheaper, because you've got the 75 and 105. Really, if you're looking at this, I could go through all the possibilities, but obviously I don't like this 55 and I don't like this 60 either. Let's just check out, can we go cheaper by using the 30 and the 20? Now 30 and 20 is 50 compared to this part, which is 30 and 40, which is 70. So 50 is better than 70. So if I just erase a whole bunch of stuff there, I can see that if I go 30, 20, 30, I can improve my route, and that is 80. And I don't think there's any way I can possibly do that. But it's not asking me for the value. It's actually asking me, let's very carefully, what does it actually ask me? It says, which other towns will he pass through besides N and S? Some people wrote down the route, which was N, Q, R, S, which was allowed, but you're actually supposed to have written Quigley and Rosebush for your Q and R. They gave 1 mark for either of those answers. Okay, so we're just verifying Euler's formula. His name was Euler. He was German, not Greek. And we got to do the V and the F and the E and prove that equals 2. It's just a different variation on the formula here. We've got no negative, don't freak out, same thing. So we've got 1, 2, 3, 4, 5, 6 V's, so that's 6. If we then look at faces, we've got 1, 2, 3, 4, 5, 6. Or do we? Don't forget the one on the outside. That's the little trick to remember there. So that's 7. And then we've just got to do edges. Let's do that in green. So I just put it like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Have I missed any? I think I have somewhere. Oh, there it is. 11. 11. So 6 plus 7, 13, and 11 plus 2, 13. So 13 does equal 13. Therefore, we've verified it by putting our numbers in there. Okay, so whenever you see these tables, you know it's going to be Hungarian algorithm. So they've given us table 1, which is the full values, and they've actually given us a table 2, where it says that they've done some part of the Hungarian algorithm to get those values. That's quite nice of them, isn't it? So maybe this problem isn't as hard as we think. So it's the final result. They've given us the final result. We don't have to do any of that sort of other stuff mucking around. Aren't they lovely and nice? So let's have a look. It says in table 2 there is a 0 in the column for colon. What does that mean? So that basically means if we've got tor2 and colon, that's what it means. We're allocating tor2 to colon. So you have to write. This is done very badly, by the way. So, Colin must plan tour 2. There we go. That's all you had to do with that. And that's just building you up for what we're going to happen to do next. So we know Colin is number 2. So then let's have a look at other zeros we got. Now tour 1 has only got the 1 0, which is by. I'll just use a different color for that. So tour 1 must go to by because she's only got the 1 0. So you do all the ones that rows that only have 1 0 to do this. So that means that by has got tour 1, and then we can look at our, grab another highlighter color here. So tour 3 has got 2 zeros in it, but tour 4 has got 2 zeros, but we can't give tour 4 to by because she's already been allocated. So that must mean tour 4 goes to Agatha. So Agatha gets number 4, and then what color? We haven't done orange. Do orange for a highlight. So tour 3, Agatha's already got that 0, and so the only other 0 is Diane. That's by elimination, really. Most of you probably wouldn't have bothered with that. You're just going straight away that the last one must go to Diane. So Diane gets number 3. All right, now we got to. The actual question is for part B: determine the minimum total planning time in minutes for all 4 tours. So we need to look back at the original values. A lot of people forget to go back to the original values. So tour 1 was, tour 2 was Colin, and by was tour 1, and Agatha was tour 4, and then tour 3 was Diane. So you just got to add up all those numbers. So you have got to do 7 plus 8 plus 10 plus 18, which is not so hard to do, and that equals 43. Don't forget to put your units because they will take marks off for this. If you just write 43, they might go, no mark for you. And so that's 43 minutes. Quite nice of them to do most of the hard work for you, just had to allocate and then remember to go back to the original values. And they sort of bridged you there with part A, telling you, go on, remember what allocation is? Okay. Quite a straightforward one. It looks like a minimal spanning tree question, and that was actually the key that many people got wrong, was they just wrote spanning tree. It says we want, for this, give a mathematical term to describe a graph that represents these cables. We were required to power the rides will form a connected graph. The shortest total length, shortest, that means minimum. So it's a minimal spanning tree. And so a lot of people just stuffed up by forgetting to say minimal on that. Okay, so now we know we need to do a minimal spanning tree. We've got to draw that onto the graph. You can do this in a number of ways. Let's do the proper Prim's algorithm. Let's look for the lowest number. That's 150. What's the lowest number, not 150, it's 50. What's the lowest number connected to the 50? It is 100. Now remember, in all these cases, we're actually looking along the entire length of this thing. So we're not just looking at this line anymore, we're looking at this and this, okay? So whenever you're doing these things, looking along the whole length. So what's the next lowest number that's connected to all of that? It is 100. So looking along the whole length, what's the lowest number connected to this? It's 150, but we can't do the 150 because it will make a face, so we've got to scrub that out. Again, what's the next lowest number? We've got two 200s. This 200 we can't do because that will make a face. We've already connected all the vertices, so it's this 200. Looking along the whole length of that yellow line, the 150 is the lowest. Looking along the whole length of the yellow line, the next one is 300. The next lowest number connected to the whole thing is the 350, but we can't do that. That makes sense. And really, if we've only got 2 dots to connect up, so just got to look at what is the lowest way to connect those. You could do this 400 because that's the lowest number left there, and then it's got to be 200. It's the only way to connect that last dot. And you can see that the 450, 500, and the 500 are not necessary. please make sure you draw that nice and clearly on these things. Most people got this right, but were unable to name the graph in part AI. That was where they lost really marks. Okay, critical path analysis time. And our first question is write down the two. So it's telling there is two. That's quite a nice hint. There are two immediate predecessors for I. Here's activity I. And the mistake that probably people did was they went, oh, I can see a dummy and a D. But the dummies, no. The dummies, remember the dummy is 0. So you've got to go back and follow that the dummy is actually E. So the answer was D and E. If you wrote down dummy, then you're a dummy. See what I did there? And you lost the mark. You wouldn't get your mark. Bye-bye mark if you did that. That's a little bit tricky that knowing that E was in there, but it told you there were two. So you did see D quite easily. But writing dummy was the common mistake. All right, looks like we've got some critical paths to look at. I think the best way to do this is to actually look at the big diagram, and then we can also look at the float time for F. It's given us a total of 19 days, so now if we fluff things up, we don't get 19, then we need to check again. We've already given one critical path, and it says there's actually a second one. So without further ado, let's look at that diagram. This is all blown up a bit bigger, and here are some boxes I prepared earlier. So we put a 0 here, and then activity A, we add 2. Going up the top with B, so that's 2 plus 3 is 5. Going across with F, 5 plus 3 is 8. Let's do some more across the middle. So activity C is 2 plus 5 gives me 7. Activity D is 2 plus 7 gives me 9, but there's a dummy coming in the bottom there. So I should put the 9 on the outside there. Coming down the bottom, E is 8, so 2 plus 8 is 10, and then the dummy coming back up is 10, so I actually choose 10 for that box because I've got the two choices, two things coming in. I've got two things coming in for J and I into this box in the bottom right hand corner, so 10 plus 2 is 12, and 10 plus 2 is 12, so it's not so hard to see they're both 12. We've got a lot coming into this point here, so coming down, we've got 8 plus 3 is 11, going across, 7 plus 9 is 16, going up, 10 plus 3 is 13, going up, 12 plus 5 is 17. Wow, that's a lot. So what do I choose? I choose 17, which is my maximum. Quite annoying to put that box in there for that for this vertex here. Coming down, we've got 8 plus 4 is 12, 17 plus 2 is 19, that's good, we've got a 19, and 12 plus 6 is 18, so my finish is 19, and that was my forward pass where I'm looking for the maximum, and I'm adding. I'm going to choose green to go backwards, I'm looking for the minimum now, and I'm subtracting, so it's 19. Going back out here, that's 19 minus 6 gives me 13. Going back up, there's only one arrow, I think, if I'm getting that right. So 19 minus 4 is 15. And then, oh dear, there's a lot to this, isn't there? 19 minus 2 is 17. So that's good because we need to do something on the critical path. Now we've got to go back against a whole bunch of arrows again. So actually the 17 minus 3 gave us 14 here. So I've already made a little boo-boo there. Let's go back to the pen, and that's actually 14 because 19 minus 4 is 15. So we could have actually had a 14 there. And then 14 minus 3 is 11, and that's going to answer a question for us because that's the activity F, and there's our float time up there. So let's continue on the rest of the process. 17 minus 9 is 8. 17 minus 3 is 14. But 17 minus 5 is 12, and that's why we had a bit of another boo-boo down the bottom here. It's very easy to make these things. So that was 13. We choose the minimum is 12. That makes more sense. The green can never be more than the red. There's our 12. Now, this is what we spotted before because we had the two 10s coming through. And they highlighted this area to us a bit with the other question about what the predecessor for I. So let's try that again. So we've got 17 minus 3 is 14 already. There's 12 minus 2 is 10. So we choose the minimum is 10. 12 minus 2 is 10. So you can see we got that splitting there. And 10 minus 7 is 3. 10 minus 8 is 2. So that's why we choose the 2. And 2 minus 2 is 0. Wow, a lot going on in there. Now they said one of the critical paths is A, E, J, L, N. What's the other critical path? It's an unusual question because you don't often get two critical paths on these kind of questions, not until you're sort of crashing or anything like that. Let's choose purple because it's nicely dark and destroying. We got the N, the L. We can now go on the I. Are we okay with that? And A, it's got to be in. A's got to be in there every time. And so where else can we go? Now this is where a lot of people made a mistake. It's using the dummy. That's the only change. Why can't we use D? And that's because of this little hidden 3 here. As soon as you get these triangles forming like this, you can have some problems. But you can see there's actually a float on activity D, which is hidden by this technique. It's very, very annoying, but you don't use activity D. You've got to include on these things the critical ones that don't have any float. And D, activity D does have a float. You can see it's got a float of 1 because there's a difference between the 3 and the 2 there. So the answer for the question, which we'll get back to in a minute, of what's the other critical path, it's not A, E, J, L, N. It is A, E, don't include the dummy. Don't include the dummy. Only dummies include the dummy. I, L, N. All right. And so the other thing was determine the float time for F. F is up here. Float time, we've actually got it quite easily highlighted there. It's 11 minus 5. So that's 6. So if we go to our answers, we can now write those answers in. We have got A to E to I to L to N and 6 days, not forgetting our units. Apparently lots of people said 7 or 5 for the second question. I don't know why they would have done that. That was quite easy sort of thing. I think part BI was actually harder, but a lot of people got that right. Oh well, students, strange things. Okay, we got some crashing questions, which are generally done very badly. So this is a good time to focus on this, get it right, and then you can make a lot of marks that other kids don't, and then your ATAR's up. Yes, this is where you need to focus. Focus on something until you get it right. Okay, particularly the second part. Now, cost of crashing is 1,000 per activity. We can crash B, D, G, I, J, and L, and they can all be done just by 1 day. So we've got to then work out the minimum number of days that it can be now completed and what is the minimum cost of completing the project in this time. We're going to go back to our diagram. We're going to play with our diagram. All right, I've got to highlight the activities we can crash. So you can crash B, and where else we got D, and G, and I, and J, and L. Is that right? 1, 2, 3, 4, 5, 6. Cool. So we can crash any of these by 1 day. Now, normally when you're crashing, you're looking at what can you crash that's on the critical path. And if you crash what's on the critical path, you've got to pay attention to quite a few things when you're crashing whether you don't flip the critical path. Normally when you're crashing, you're actually making more and more things become simultaneous critical paths. So if we look at this, we're probably not going to reduce B because it's nowhere near the critical path. But D and G look a bit suspicious, especially D because we had that only one float time. But if you look between C and G, there's this 7 and 8 with only one float time. So it's not looking great. Let's have a look at what we can do. Let's use a blue highlighter. I can crash J by 1, then that changes, and I've got to crash I by 1 as well, so they can both be at 11 because they're both on the critical path. They both need to be crashed, so that make that 11 and 11, which makes that 11, and so 11 plus 6 actually makes that 17. But going up here, 11 plus 5 makes that 16, but we can crash this as well and make that 4. So that takes one off that makes that 15. And then we can crash, so if we 15 plus a 2 makes that 17. So we've got two 17s coming in now. So we've got 17. That looks pretty good. What's gone wrong? Pay attention. We've got this 15 here, but remember we're doing the max plus we've got a 16 coming in here now. So the 17 has dropped below the 16, so we're going to have to crash G by 1 and make that 8 so that this becomes also 15. And that means that you've actually added in a new critical path. This is also a critical path now. So you've got 3 critical paths, yay! So the whole thing is 17. So a lot of people got this right because they didn't spot, I'm running out of colors. This is how crazy these diagrams are. I'm running out of colors to do highlight. They didn't spot this thing, all right? So that whole thing was spotted because you put these little red numbers coming in that you can, these little red numbers here, they really helped you. So make sure you do those sort of things and seeing that, you got to do your forward pass again and go, oh, wait, there's a 16. So I had to reduce 4 activities. That's 4 lots of $1,000. So the new minimum time is 17 days. We found that out over here. So it's 17 because we got a 17 coming in here and a 17 coming in here now. But we don't forget to reduce activity G. Only 15% of people spotted that the activity G had to be reduced. Ah, dear. All right, so the answers were for those two things. So we said 17 days, and because we had to crash 4 activities, that's 4 times $1,000, and that equals $4,000. That was a big mark to get to spot that little G. So again, don't be afraid of the tricky questions. They're only hard because you haven't not done them many times. But when you do them a few times and you do this over and over and over again, it'll become easy to you and you won't be afraid of them anymore. And you'll get past those people who have anxiety attacks and are afraid of them. And you'll beat their ATAR. And they'll go to you, how come you did so well on the test? And you go, yeah, I don't know, just lucky, I guess. And you're not lucky. You studied hard.